Hi there, and welcome back to Programming and Coding Basics with VBA, Python, and Java with JavaScript, brought to you by QuadRoot R&D. Now, this is the final video, which is a hands-on exercise on a simple, fun program which I invented called LifeDecisions. Now, do you know those moments where you can't decide whether you want Indian or Chinese or pizza, and you literally have to flip a coin? Well, I don't have a coin anymore, so I've downloaded an app which is called a flip coin app, and it just basically flips heads or tails, and then based on that I make a decision sometimes. But what if that decision was a little more serious? What if it was something like, taking a year off or getting married or having a baby? Well, those kind of things you can't really leave to a coin toss, can you? So what if you could ask, one of those devices, which I can't name for legal reasons, hello, what should I do with my life? And you would hope to get a sensible answer. But the other day I asked one of those devices, and the device just searched on the net and gave me a list of 10 things that I could possibly do, which were just pretty much read out from a web page it found. So what if I wanted something a little more intelligent? I'm not saying now the most artificially intelligent answer, but at least some sort of thinking or logic behind that decision. So that's why I'm calling this a pseudo-AI exercise, which is basically just using the very basics of programming and applying it to get some logical answer to a simple, well, maybe not so simple question, which is, what should I do with my life? So when I'm asked that question, I expect to be asked back some follow-up questions like, where are you currently? Do you have a job, or do you have some savings? And that's what you'd expect if you were asking, say, a confidant or a parent for advice. So that person would know something about you. But if it was a stranger, then that stranger would ask you some follow-up questions and maybe give you some advice. So really, the more data the program has access to, the more intelligent the answer can be, which is why data science is closely linked with artificial intelligence, because you make intelligent decisions out of data and statistics and so on. But we're not going to go to that level. We're just going to use some simple logic that we've learned in the first 3 hours of programming and coding basics, and we're going to apply that to give some sensible answer. It's a fun exercise, so don't take it too seriously. I'm not saying you take a year off and quit your job, but just to give you a brief flavor of what's possible with very simple tools that we've learned before. So it's going to be a bit like tossing a coin, but it's going to do some viability checks based on your current circumstances. So before we get started, we're going to use Python. Now the reason for that is it's fairly simple. Since this is going to be your first major program, not everyone has Excel installed on their systems since it's a paid software, whereas Python is open source and you can download it as I've instructed in the previous video. So the prerequisites is that you finish the 3-hour course on the basics of programming and coding, where we discuss problem solving process, which is the first thing we're going to do, data types and variable declarations, which is the next thing, then IO statements, operations, loops, branches, and functions. Now, if you haven't already, please install Notepad++, as we're going to use that as the code editor. And of course, you need Python 3.x install, and both these links were given in the previous video in the description. So you can go install that. It's pretty straightforward. I don't need to walk you through that. Just click next, 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 agree on the terms and conditions, and choose the default settings. So if you haven't done that already, pause this video, do that, and come back here. Okay, so the program brief is basically, the objective is to suggest a course of action where when one is confused, what to do with one's life based on their current circumstances. So this second bit is the intelligence, so to say. So based on their current circumstances. So the strategy we will use, and this is not the only strategy, you can have different strategies, but this is the simplest strategy that I thought of in the first instance. So we'll use a random function to guess an action. So a bit like tossing the coin, which is a fun thing to do anyway. So we'll use the random function to guess an action from a predefined list of actions. So we're going to pre-code or code into hard code some list of actions, possible list of actions. But then we're going to eliminate if that action is not viable based on their current circumstances, and then re-guess. And we'll do the viability check. If it's not viable, re-guess, and so on till it's viable. And then if it's viable, we give that. So it's sort of, we do that viability check, which will be the intelligence bit, and as the filter. And if it's viable, then we'll suggest. And the input-output method is not going to be fancy. We haven't learned about user interfaces or web pages. So we're just going to use basic user inputs, and we're going to display the output on the screen. So as I've said, as I promised, in these first 3 hours, we're just going to learn how to write the engine of a program, which is the basic, the brains of the program, basically, and no fancy user interfaces. So let's get right to it. Now, the IDE that I've chosen, basically, it's not the complete IDE, it's Notepad++, which is going to be the code editor. And we're going to debug using Python install the runtime environment. So I'll make a sort of fancy IDE. I'll just construct one on my desktop. I'll start off by starting the command prompt, you typing cmd in the run button, and I'll keep it to C:, where I'll store my program. Now, if I just want to check if Python's installed, so I just type in Python, and it will show me the version of Python. And now it's in the Python idle environment. So I'll exit out of that by clicking on Control-Z. And I've exited out of Python. So we're just going to run the program here, which will use Python. So this is going to be my test bit of it. I'll then navigate to my downloads folder, or any temporary folder. And then I'll bring my Windows Explorer, which is in the same folder in C: downloads. And I'll create a new text document. But instead of renaming it as something.txt, let's say LifeDecisions, I'll replace the txt with py, and that's going to be my Python extension. And so now that is a Python file. So LifeDecisions.py, and I'm going to right click, and I'm going to edit with Notepad. So if you have installed Notepad++, you will see the option as edit with Notepad++. Click on that. And you'll see it's open in a blank file and some previous files, which are basically the previous examples that I've written for the course. And it's empty. So just to test my program, I'm just going to say print hello. And then in the command prompt, type in LifeDecisions.py. And this is basically running the program. And it says, well, I forgot to put hello in quotes. Silly me. Well, this is what happens. This is debugging. And I click on save and I run it again. And now I just click on the up button. And it remembers the last command. Run it again and it says hello. And so that's my program. So now that we know this is now my IDE, I have my code editor here and my debugging console over here. So let's get to the program. Now let us start writing out the algorithm in comments. So the first thing is we need to declare the variables. And we do it by initializing them in the same instance in Python. Initialize. And the next thing we would need to do is since we decided to pre-code the outputs, the possible actions, we'll list out the possible actions for the user. And how are we going to do this? Well, we'll list it in a list or an array. So we're in an array. And then it's time to get some inputs. Get user inputs. By prompts. And we're going to ask it some questions like, what shall we do? The age. And this is going to help us declare and initialize the variables because we're going to make variables for each one of them. So let's say age and then sex. Do they have a job? What is their salary? Do they have any savings? Do they have a house? Are they married? Do they have kids? Do they want kids? But wait, do they want to get married? So let's put that over here. And if they have kids, how many kids? Let's say number of kids. I think that should do for now. So based on this, we're going to randomize between the possible actions, and then based on the strategy we chose, we will check for viability. Of the chosen action. If it's viable, print the output. If not, or else, reguess. So I think that's pretty much the algorithm very broadly. Now the viability check is going to be a little more, will have to be a little more detailed, but we'll get to that a bit later. So let's start with declaring and initializing the variables. Say we have variables for each of these. So let's just copy this because these are the inputs we're going to ask. And we'll start initializing them with variables. Say, so age is going to be an integer, so we'll just put 0. Sex is going to be a string, so we'll keep it to initials. So we'll just put an empty string right now. And a job, well, do you have a job? So it's going to be a yes or a no. So we'll keep it as a string, because if we could keep it as a boolean, like a true or false, but ideally, however, we'll just skip that step and just use a string, and we'll initialize it with n for no. So we will just initialize it for the worst case scenario. We could have put it as a empty string, but since we're not going to do any input validation, just to save time, we'll initialize it with some safe variables and say no. Salary, well, salary is going to be an integer. Savings is going to be an integer. Do you have a house? This is going to be again a boolean, but we'll just keep it as a string and we'll initialize it as n for no. Are you married? Again, n for no. Do you want to get married? We'll initialize it as n for no. Do you have kids? Again, we will initialize it as n for no. Do you want kids? N for no. And the number of kids, well, this is obviously going to be an integer. So we've initialized it with some safe values. So now we're going to list out the possible actions for the user in an array. So let's say we'll name this variable as a result, and it's going to be an array. So now this is going to be the output, basically the possible outputs, the list of possible outputs. So they're going to be strings. So we're going to start with something. What are the big decisions that you take as you age from a young adult to age-old to retirement? So the first thing you do is study, really. And then you get a job. And I'm being very traditional here. Then probably you switch jobs if you're in your slightly mid-career or something like that. Switch jobs or careers. What else? You could get married. This person, very traditional. Then you have kids. Then you buy a house. Then maybe a fellow of your job, so you start a business. What else? Then you're just tired, and then you just want to take a break, so you take a study sabbatical. Or you travel for a year. Or maybe it's time you just retire, mate. So let's stop at that. I think that's enough. How many have we got? We've got study, get a job, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we've got 10. That's enough now. So we've got our output array where we will randomize between one of these. So let's start getting the inputs. So the first thing we want is age, but generally most, websites that don't ask you for age, they ask you for your year of birth, and then they calculate your age, because if they're going to store your age next year, that number is going to be not valid. So they might as well store your year of birth, and then calculate the age, and that is then valid for many years. So instead of age, we will ask you for your year of birth. So let's start with, we'll have to make another variable called birth year, and we'll integer that, and we'll say birth underscore year. Now, in order to prompt the user with a message for an input, we use the input command, and then we put our prompt in as a string, and we say, please enter your year of birth in YYYY format. And then we'll put a colon and we'll keep a space just to keep it neat, and we'll close that quote. And so this will prompt the user for the year of birth. Now remember, for integers and numbers, we have to put an eval statement, because otherwise Python will read that as a string, even if you put a number. So for numbers, we put the eval statement. So I've put that inside the eval. The next, then we will just quickly calculate the age, but for that, we need to use those datetime functions, but they're not readily available. We have to import that. So we will input that before declaring the variables, and we will say from datetime import datetime. So the library and the function is the same in this case, and we will now get the current datetime, and so we'll just initialize a variable, say d is equal to, and if you refer to the cheat sheet, you will see that the datetime function is datetime, and open the bracket and say 1 1 1 dot now. That's telling the format of the datetime, and we're saying we want the datetime of now, and we'll store that into d, and then we'll calculate the age, which we've already initialized, but now is the time we'll use an operation, and we'll say d dot year, which is the current year, minus birth year. Okay, but the thing is that the d dot year could be in the form of an initial or something like that, so we want to avoid that, so we just so just to be safe, we will round that down to 0 decimals. So I'm just basically going through a lot of the functions that we discussed in the functions video. So just in case it was any decimals, we've just rounded that down to the closest year. So now we've got the age. The next thing is now we're going to ask for the sex. So let's say sex is equal to input. What is your sex at birth? And we'll give some options. For male, you enter M. For female, you enter F. And for other, you enter O. We want to be inclusive here. So if we leave a space and close that, oops, I forgot to make that a string, and we close that. Now this is going to be a string, so we don't need to use the eval function. So we got our sex. Then how about job? Well, so the next thing is job. Now this is a yes or no answer, so job is equal to input. Do you have a job? Now we'll do some, yes, we'll also include some options. For yes, put a Y, and for no, put an N. Now let's say if you don't have a job, then I shouldn't be asking this salary. So let's make the inputs a little more adaptive. So we'll put this. So if job equals to, and it's double equal to, I always make this mistake, to yes, then we will ask for salary. Okay, and this is going to be small lowercase for Python, else we will, now I have used indents here and I'm using the tab for indents. Now Python's quite anal about this. If you're going to use spaces, then always use spaces for indents. If you're going to use tabs, always use tabs for indents. You cannot mix and match. So we'll keep salary equal to 0 if you don't have a job. Okay. So now you can leave a space, keep things neater. It's not a must, but yeah. When you're coming back to the original indentation auto level, then better leave a space. Okay, so why I thought of this is because if you aren't married, then do you want to get married? So similar kind of this thing. So if you're not married, do you want to get married? You know, nowadays people don't want to get married, and that's okay. And we'll, if the person's not married, if the person's married, we'll say the person doesn't want to get married, just in case that person's not polyamorous or polygamous. We're not that inclusive here yet. Just trying to simplify things for us for now. So now we'll move on to kids. Or do you have kids? Yeah, let's go for asking them if they have kids already. We can probably just directly get the number of kids, and we can say we don't have to. We can use this. We can save ourselves the trouble. So we'll say we'll eval this. How many kids do you have? And we'll prompt them 0, 1, 2, ... So we'll say, what we'll do is if they already have more than 3 kids, we will not even suggest them to have more kids. So we'll only ask them if they want kids if they have less than 3 kids. If num kids greater than 3, or let's say less than 3, then we'll ask them want kids. Input. Do you want kids? And yes with Y, no with N. Else want kids equal to N. No more kids, guys. The world can't handle it. In fact, yeah, let's keep that at less than 3. So 2 kids is the max. Let's not burden this planet. Okay, so I think we've got all the inputs, else we're going to be here all day. So now let's move on to the next bit, which is let's now randomize between the possible actions. So we're going to use the random function, but for that we need to use the random library. So we need to import that. So we'll say import random. I could say from random import randint, but I can also import the entire library. We'll name the variable as guess, which is, and then we'll use randint, which is in the random library. So random.randint. And since we have what, 10 possibilities, so we'll randomize between 1 and 10. Okay, so this will randomize a number between 1 and 10, and we're going to then use this number as the index for our result variable. So we'll have to remember -1 because the indexing starts at 0. So whatever integer we get, we'll minus that. And then we will output that in the end. So we'll do that in the end, the -1 bit. But for now, we will keep things simple. And 1 is study for now, and 10 is retire. So yeah, so now we have to check for viability. Now, because of the way we structure our code, before I would have used a go-to statement. So we would do this and then we come back here and we would check for viability and we come back here. If it's not viable, come back here. But we don't like that go-to statement. So we have to use one of the loops or branch statements. So when we have to do something continuously till we meet a condition, what do you think is more appropriate, a loop or a branch? Well, it's a loop. So we will use the loop and we will put this within that loop. Okay, so in the loop we'll put this, we'll do this, and then we'll check the condition. And or rather we'll check the condition while loop. So let's write that loop. So while, and now we'll give a condition. We've not yet given the variable, but we'll specify that. So let's say while output. So this, we're going to output this a bit later. So output equals not viable. Do whatever's below this. Okay, so we'll have to put a colon there. Now we haven't really initialized this, so we will initialize this as not viable so that it does this action for the first time at least once. Okay, so we will initialize it as not viable, so it checks as not viable and then it will do this. And so we will put this bit here. Okay, so now it has guessed. So we'll imagine the first run is not viable. We'll do the guess. This is now the first guess. And now we will check for viability. Okay. And so but there are 10 possibilities. So now we have to code in all 10 possibilities. So let's start with, we will put, and, you can already imagine how we're going to check for viability. We're going to use branches. So we're going to use conditional checks to check for viability or non-viability. So, but we're going to, based on assumptions, based on programmer's assumptions and some specified constant. Okay. So now we will say if. Now let's say it guessed 1. If guess equals to, let's put a space just for neatness, equals to 1. Now we want to check for viability of, and now what is 1? It's study. Now we don't want to suggest someone to study unless it's a sabbatical, so that's a separate thing. But we don't want someone to go start studying beyond a certain age and say, let's say that age is 24. So we'll add another condition using the AND operator, and age greater than 24. And this is really the limit, I guess, to study. But people want to make money at this time, so I think let's make it 22. Being a bit harsh, but trying to make money. So if the age is more 22, guess 1 is not viable. So we'll say output equals not viable. So we'll keep it as not viable. And so it will loop again once it reaches the end of this. Now, if it was viable, we would change that to the final output. And we would say else the output is equal to, now we would have to output one of the results here. So we'll say the result, and we'll give it the index number of that output, which is the guess, -1, if you remember. So let's space that out. Just for neatness. Okay. So I think we've gotten pretty far. So I would just say let's test our program, how it's doing. And I'm testing it. Let's see if there are any syntax errors. And yes, I did find some syntax errors. So it's equal to here. So it's while output is equal to. I always make that mistake. Now we'll do for the remaining. We'll put some logic for the remaining. And I'm going to just make things a bit faster. So that's for first, that would be for 2, 3, oops. 4, 5, 6, 7, 8, 9, 10. And let's put that as 10, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's see. Now, let's say now we check for viability of option 2. So for option 2, what is that? Get a job. So you can't really get a job before the age of 18. So let's say, so this thing age is less than 18. Okay, so what else? And if you already have a job, then you don't want to suggest to get a job, right? So we'll check for and, or really it's or in this case. But what we want to do is, and I'll show that a bit later. So we say job equals to yes. Okay, so now if guess is 2 and we'll put this whole thing as one condition. So then it treats it like mathematical operators. So it does everything in the brackets. So this or this, if this either of this is true and the guess is 2, then output is not viable. Okay, so if it's get a job but your age is less than 18 or you have a job, then it's not viable. Okay, so I think that's good enough. How about guess 3, which is now switch job careers? So you don't really, again, I would say we can copy this. You can't really switch if you haven't had a job. And now in this case, you can't switch a job if you don't have a job. What else? Now, if, say, earning a really high salary, then you don't want to really rock the boat, say. So let's just say if you have a very nice salary, greater than 100,000, then yeah, you stay with this job. Unless it's really soul destroying. So let's put that as a condition. So yeah, what's the next one? Get married. Okay. What should be the age of this? Yeah, I think you should be enjoying life before, say, 25. So if age is less than 25, or age is greater than, say, 75, you know, can't really get married. And we need to put a age limit also for getting a job over here, which is option 2, and switching jobs. So we'll put an upper age limit of, say, 65. And if you're married, 75. But if you're already married, then equals to yes. Then we don't want to suggest you to get married again. But if you've said you don't want to get married or want married, see the drop down, auto drop down. So want married equals no, then you don't want to get married. So you don't want to suggest that. What if you don't have money to get married? So you need to have some savings, right? So all savings less than, say, what, 5,000 a decent wedding costs, GBP. That's Great British Pounds, if you're wondering. So you can think of dollars also. You need some money to get married, so don't suggest marriage until you have the money. Okay, what else? Okay, I think that should be enough about marriage. What about 5? Have kids. Well, again, now this is a bit tricky because you'll have to bring in your gender and your age. So guys, don't have kids before 25. So I'm going to say 25 for this. But the upper age limit, so now this is going to be tricky because we're going to have brackets within brackets. So now for the upper limit, so if the age is less than 25, or, and within this we'll have the female upper limit and we'll have the male upper limit, and we'll have some savings also. We'll say we'll probably bring into account the number of kids. If number of kids greater than 2 or greater than 1, and or savings less than, say, 5,000. Okay, so now for the upper age limit, for we'll say 35 for females. So, and I mean the risk does go up by double after 35, so let's not suggest kids after 35. Okay, let's push it to 37. Okay, and yeah, this is for females, so and sex equals to female. Okay, or let's copy this. I'm going to say sex not equal to female here because it could be other, and we're assuming the other will have others won't be able to reproduce in the sense have babies, so let's just give a higher age limit, say 47. So for the non-females, the age limit, upper age limit is 47. So num kids greater than 1. So if you already have more than 1 kid, so 2 kids or more, we'll not suggest this. Or if you have less savings, we'll not suggest having kids. Okay, it's not viable. Okay, great. So now let's talk about buying a house. Again, there's no, age limit. So for option 6, but maybe let's say let's keep that 25 because you've got other things to do before that. Don't want to buy a house also after a certain age. You don't, the sense of the problem of mortgage, you'll not get a mortgage unless you have some savings. So let's keep that, give an upper limit. Or if you don't have a job also, like, so, or job equals to no, I mean, you're not going to get a mortgage. Or say, what else? You need a certain salary also to sustain the mortgage. So let's say salary is less than 25,000, say. Okay, and then you need some savings. So I could hard code some savings here, but when it comes to buying a house, when you ask for mortgage, they look at your savings and your age, and so they have some sort of formula in their heads. And so I don't know what that formula is, but I've sort of thought of some ratio basically. So the higher the age, the higher the savings that's required. So you need to put in more deposit basically to get a mortgage, and you'll get a smaller mortgage as you're older. So I'm going to sort of increase the savings requirement for the age, but by squaring it, like, so it's going to be savings divided by age, and we'll square the age because so it's very sensitive to your age. So if you're 40, you need like a lot more savings than you would need when you're 25. And that ratio I've sort of calculated as so if it's less than a certain ratio, then you wouldn't be viable. So that is that, and this bracket's closing the entire thing here. So now basically what this is saying, suppose you're age 30, so 30 squared is about 900, and you have to have 900 into 30, so that's about 27,000 pounds of saving for your 30. If you're 40, so that's like 1,600 into 30, so that's like 48,000. So you need like 48,000. So it's a sort of slightly intelligent. It takes into account the mortgage decisions taken by banks. It's just a rough guesstimate. And I think, that should be enough to determine if you can buy a house or not, the viability check for a house. Okay, what's next? Start a business. Well, for this, I wouldn't say that. I think you need a bit of experience to start a business. So, and you don't want to be too experienced. So let's give this 30. So let's. So let's say get some experience, guys, first. And I don't want to suggest a business after. You don't want to suggest too much stress. So after the age of 70. So what else? If you're already earning like a cushy salary, then I wouldn't suggest starting a business because it's going to be tough to beat that. So let's say salary greater than 200,000. Okay. And if you don't have enough savings, you need some savings to get by for, say, at least 6 months, say. So let's say £6,000 to get you by 6 months. Okay. So yeah, I think that should be it for starting a business. Otherwise, not too many barriers to starting a business. What else? Take a study sabbatical. So this, you need a little more savings. So let's say a lot more savings. Again, I would say similar to this. I'll just change the constants in here. Say you deserve a sabbatical between the ages of 25 and say 60, because beyond that you're close to retirement. Let's say 55, and your salary says, say, greater than, I don't know, 80,000, something a bit like this, say 100,000. Like, you know, if you're earning 80,000, why do you need to take a sabbatical? It's going to be a bit difficult to let go of that salary, and you need some savings, a lot of savings. So let's say, what, 10,000. I'm just picking up values off the top of my head, so you can make this a little more intelligent. You could base it on data also, so get some statistical data, and then, you know, change these constants. Okay, so I think that should be good enough for the study sabbatical, viability check. What's the next one? The next one is travel for a year. Again, very similar things. So I'm gonna, say, now you can travel later, so yeah, you should be earning money before 25, but let's say you can travel up to 80, and you don't have to have a salary to travel. You'll need a little more savings though, because you're gonna spend a lot while you're traveling. So let's double that savings. If you're gonna study, also you'll need a savings money for the course, right? So yeah, so let's make that 12,000. Yeah. So yeah, so that's pretty much to travel. Less barriers to travel. Okay, and then finally retire. I think we'll put it like if the age is less than 50, you don't need to retire. You can work. Don't consider yourself. Or what else? So if you haven't had enough savings, so you need some savings to retire. So I would say at least 500,000 or 200,000. 200,000 in savings. Or if you don't have a house, then you should buy a house first before, because I should be using equal to here. I always miss this. So these are logical checks. So not equal to. So if you don't have a house, then I would say don't retire yet. You need to save more money. So yeah. Or am I being too harsh about savings? Maybe you can, because you need money to survive for the next 50 years that you're going to live, and you need at least 10,000 a year. So consider you earn interest on this. So yeah, at least 200,000. Yeah, this is still less, but yeah, let's say 250,000. Okay. Oh wait, that was for 9. Yeah, so that's our viability check. Now it's time to print. So let's print the output. And output is a variable, so it doesn't need to be in quotes. And that's pretty much it. Now, when we're using loops, we run the danger of it looping forever and not reaching, in this case, a viability. So we need to be able to stop the loop. So we'll use that by giving it a certain limit. So we've given it a condition, but if the condition is never met, then or the condition is never broken in this case, then it'll loop forever. So we'll give it a hard condition stop. So we'll say we'll start counting trials, and so we'll use a variable called trial, and then we'll indent that as trial plus, sorry, we'll increment that as trial is equal to trial plus 1. So we need to specify this before the loop. We'll say trial is equal to 0. Okay, and so we will then say if trial less than, say we'll give this 100 tries. If it can't find within 100, then you're pretty much sure. Then, so for the first 100 trials, we'll do all of this. Okay, so I've tabbed it now. And if it's not, then we need to break out of the loop, but we can just break out of the loop by giving it an output that is not viable. So we'll give it a different one. We'll just say output is equal to, say, could not decide. Hang in there, you know, because it was really, the person was really hoping for a decisive action from this program, but it couldn't find one, so we have to be a bit supportive here. So, and just for fun, just for us to check, we'll just print the number of trials. Okay, now this is the number, and we'll just output the string space trial. So you'll get the number of trials, and we'll just the word trials. Now the thing is that when you concatenate an integer, this is going to be an integer with a string, it will fail because it only prints strings. So you need to convert now the integer into a string, and we do that with the str command. So I'll convert the integer into a string, which will be like, say, 53. So 53 trials. Okay, so we'll run that and see how we're doing. Now I'm going to give, like, I'm an old person, so I was born in 1940, say, and I'm male, and I don't have a job, and my savings is like 50,000. And I have a house. I'm married. Yes, I have 3 kids. Oops. And it's saying trials not defined. What do you mean trials not defined? Oh, it's trials. Trial. Singular. 1920, male, yes, 20,000, 1,000, yes, 4. Something's wrong here. It should not have given me have kids. One, two, three, four, five. So, I see what I've done. I've used if. I should have used elif for else if. And that's the danger of copy pasting your code. So it's good that you've seen this, because these are the typical silly errors that you tend to do. So that's if and else, if, elif, and then else. That's done. So let's do that. And I'm 19, 21 and male, and do I have a job, and my salary is 33 and your current savings is 2, and I have a house, and I'm married, and I have 5 kids, and could not decide, hang in there. So it conducted, I'm 99 years old, and it conducted 100 trials. So I think we're safe to remove this, and I think our program works finally. So let me just do one last try, and say I'm 19, say year 2000, 20-year-old, female, doesn't have a job, has no savings, doesn't have a house, not married, yes, wants to get married, doesn't have any kids, does want kids, study, and it did that in one trial. Okay, so I think it works, and so that's it. That's your LifeDecisions pseudo artificially intelligent program. Much better answer than one of those devices gives you. So I hope you got something useful from this. We used everything that we've learned. We used your loops, we used your if else, elif else, the input output statements with eval, and some functions like round and random or randint. We also learned a new one called string. Well, that's like the opposite of eval, where eval converts a string to a number, and the string str converts a number into a string. So we saw a lot of these logical operators, equal to, and what else? The datetime function. Libraries, so the datetime and random libraries. And so with just these very simple building blocks, basic building blocks, we build this semi-intelligent tool. So I hope you got a lot from this course. It's not the end, and there's a lot more coming in terms of intermediate level programming and advanced programming and data science and web design and app development. So stay tuned, and don't forget to subscribe, like, and share. Thank you very much for attending this course. See you in the next course.